So letter C is a way that we can actually expand binomials without using Pascal's triangle. Um, I will say typically my kids like the triangle better, but there's just times where this works a little bit easier when it's a bigger number. All right, so the first thing that you want to understand is the word combination uses this formula. If we're choosing n objects r at a time, we use this n factorial over n minus r factorial times r factorial. Now, there are a couple of different ways we can notate this. I put the n down at the bottom. NCR, or in parentheses, n choose r up and down. And you can actually do these on your calculator, and I will show you how to do that. All right, so when you see this notation, you just use the binomial coefficient. You use that formula. And that's how we find, Pascal's triangle. That's how we find the binomial coefficient part of it. Okay. So I also wrote down that the n choose r is the coefficient of a to the n minus r times b to the r, with your a plus b to the n. Okay, so we choose this r by using the exponent of the second term of the b term. Okay, so the first thing we want to do is take your calculator. This is just showing you the triangle and how to do this on your calculator. So grab your calculator. Now, everything but your statistics. If you want your calculator to calculate something, you're going to push math. So push math, go over to PRB, use your right arrow, go all the way over to PRB. So math, PRB, this is for probability. These are all the probability functions. Number 3 is NCR. This is your combination. When you see this in parentheses, you're just going to use the NCR button. Okay, so first you have to get out of there. You have to put the first number in as your n number. So push 1, then go to math, prob, down to number 3, NCR, and if you plug in 0, you get 1. So remember, it goes 1, 1, 1, 1, 2, 1, and so forth. So I will tell you, anytime the choose 0, anything choose 0, there's only one way to choose the 0 items. If we're only choosing one thing, if you're choosing 1 out of 1, there's only 1. If you're choosing one thing out of 2 things, there's 2. So if the bottom number is 1, this is going to be 2, 3, 4, 5, 6. Where it gets hard is in the middle here. So let's look at this middle row. The 6th row, the 6 choose 0. And I don't think you need to do every single one because you know what the triangle is. I want you to get good at the notation and using your calculator. So 6 choose 0. That's just going to be 1. 6 choose 1 is going to be 6. Let's plug this 6 choose 2 into your calculator. So you have to push the 6, then math, prob, oops, I didn't pick the right one. Go down to 3. 6 choose 2 is 15. 6 choose 3. And you know what? If you use your up arrow rather than redoing it every single time, use your up arrow and highlight the NCR2 and hit enter. It brings it down and you can just change it to 3. 6, choose 4. But understanding how to use your calculator is kind of important. 6, choose 5. And if you remember, it's symmetrical. So see 1, 6, 15, 20. Once I go back down to 15, I go back down to 1 and back down, or 6 and 1. But the only thing I really wanted you to focus on is how to use your calculator to find each of these things. Okay, so once you're comfortable with that, you can go ahead and move on. And this is the crux of the lesson. The binomial theorem states, because this will be in your formula booklet. Oops, sorry, I wrote over that. In order to expand a plus b to the n, we always take the first term to the highest exponent, plus, instead of using the triangle, we can use n, where we get the n from the exponent, n choose 1, a raised to the 1 less than this one, and b goes up. And notice the general term is always n choose r. Now, what's really important about this r comes from the exponent of the second term. And so we can use this and expand it. This is your general idea here. That's what's in your formula booklet. So you need to understand the summation is everything. And many times we just want a specific term. So it's kind of like plucking this specific one out of the middle of the formula. So here's your general term. That might be nice to write down. And then let's look at some examples. So this is just an alternate way we can either use Pascal's triangle or we can use the binomial theorem. So this says write down the first 3 and last 2 of this expansion. Do not simplify. So we just have to get them set up. All right. What's the very first one? Is the first term. Now, one thing that was kind of helpful, understand when we have A and B, A is the first term, B is the second term, and if there's a minus here, you would include that with B. N is the exponent. Okay. Now, R, I think, is always the hardest one to find. So let's kind of work through this to see, because R changes throughout each term. All right, so we always start with the first term to the highest exponent. This is our first term, plus our second term. This is where we start with our binomial coefficient. I'm going to wait to fill this in because I'm going to show you something. So my first term, 2x, goes down, and my b term goes up. Whatever the second term exponent is your r. So we're just going to fill that number in. So sometimes leaving this blank, writing this out, and using this exponent is helpful. And remember, from when we did Pascal's triangle, these two must always add up to n. So here's this whole thing will turn into my second term. Plus, I need the first 3. I need one more. So this will be 12, choose 2, because I know that's always going to go up. Once I know that one, the 2x goes down. The second term goes up. And I check this adds up to 12, and this last one matches this. All right, then I'm going to say dot, 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 and do the last two. All right, so I'm not really sure what this number is going to be. I'm going to fill this in though. So here, and I'm going to have this one is going to be 12, choose 12, my very last one. It might help to do that one first. 12, choose 12. I don't have any of my first term. My last term is to the highest exponent. So does it make sense? This one, I'm going to need 2x to the something. Oops. This is going up. So if this is 11, this is 1 because they have to add up to 12. These two add up to 12. And this comes from that exponent. So sometimes it's a process that you kind of got to work through, and you just kind of play with it until you can put it all together. So I'm going to use some of this to help us on the next one, because what if we just need to know some random term? So here on the first term, R is 0. You see that? Because there's no second term. On the second term, R equals 1. On the third term, R equals 2. So one thing that you want to understand, R is 1 less than the term you are on. Okay, so for example, if I want the 7th term, so this means I don't need to expand all 15 terms. I only want the 7th one. If I want the 7th term, that means R is 6. All right, so in this particular problem, we can go even further. What is n? N is the exponent. 14. What is a? 3x. And what is b? Negative 4 over x squared. Now we just plug everything in. So we don't need the expansion, the summation, because that's every single term. I am only looking for this specific term, so I'm only going to use one part. So this is n is 14. Choose r, which is 6. 3x. I'm going to wait on this exponent because I want to show you something. Negative 4 over x squared. Let's think about these two exponents. They add up to 14, but this one matches the bottom. This is r, this is r. So this is 6. And if this number plus this number is 14, this is 8. So sometimes you want to put in your combination, and each term you can fill the exponents in as you go. And this also said do not simplify, so this is all that we need. Okay, I'm going to star this one because these are the types of problems that I see in the IB testing. Okay, so this is where we see the expansion. Sometimes they don't want a specific, like the 7th term. They want the term that contains a specific variable. So you've kind of got to play with it a little bit. All right, so if we notice, n is 12. A, first term is x squared. B is positive 4 over x. Now, there's all sorts of ways. We're going to have the binomial coefficient here. We're going to have x squared to some power here. And we have 4 over x to some power here. So we kind of fill in these exponents and these numbers, although this has to be 12, right? That's our exponent. But we fill things in and we want to get a result of x to the 6th. So this is what I did. I thought, let's just kind of play with it. What if this exponent is 8? That would mean this is 4. What would that look like if I would simplify x squared to the 8th? I would get x to the 16th. What if I simplified 4 to the 4th, x to the 4th? See that? So if I just look at my x's, because I just really need to know my x's right now, if I have x to the 16th over x to the 4th, when you divide bases, subtract the exponent, I get 12. All right, I'm nowhere near 6. That means I'm going to have to get this number lower and this number higher. So let's try this again. This is going to be 12 something. All right, so let's try going down to 6. If this exponent is 6, this exponent has to be 6 because 6 and 6 makes 12. How does this work? So x squared to the 6th power to a power we multiply, we get x to the 12th. If I raise the second part to the 6th power, I get 4 to the 6th over x to the 6th. And when you look at this, we get x to the 12th over x to the 6th. Dividing bases, subtract the exponent. This is what gives me x to the 6th. So what they're asking for, when you get x to the 6th, what would the coefficient be? So let's plug in our numbers now. All right, so if this is the right combination, if this number has to be 6, this number has to be 6. So we have to find what is 12 choose 6. This is where you do your 12 choose 6 on your calculator. So we're going to get a value of this from here. And do you notice we also will get part of the coefficient from 4 to the 6th? Because the variable will be x to the 6th. What we're looking for, what would the coefficient of this be? So take whatever you get for 12 choose 6, take that times 4 to the 6th, and you get 3,784,704. So this is the answer to part A. Now, be very careful. They just want the coefficient. So you would not include the x part. I just want the coefficient. But you want to show your work because then you would get points for coming up with all of this. And then you get your final answer, your final point by writing this number down. Okay, part B then says, how would we get the constant term? Now, typically your constant term's at the end, but our constant term, let's think about how we were manipulating these two pieces. My constant term's gonna come when I divide, when the numerator is going to be the same as the denominator, because then I'll get x to the 0 and I will just be left with our constant. There will be no x part of that. All right, so if we had our first one to the 8th power and we got x to the 12th, then we raised it to the 6th power, we got x to the 6th. Let's try looking at it, putting this power to the And you got to play with it. Sometimes you get it, sometimes you don't. Let's try this to the 4th and this to the 8th. And let's see if this would happen. So this is power to a power. That would be x to the 8th times 4 to the 8th over x to the 8th. Notice these will cancel. So this is my right combination to get a constant. So that means r is 8. So I can move over to here and find the coefficient, my binomial coefficient. By 12, choose 8. Use your calculator to find that. So my constant for letter B will be the 12 choose 8 coefficient times 4 to the 8th, and that will equal 32,440,320. This is my answer. So we're going to take a couple of days to work through some of these because these are tough.